So hi everyone, so today I will explain about chapter 3, displacement of statically determinate plane truss. Okay, so after chapter 2 you learn how to calculate the member force. So now we will calculate the displacement. Okay, so what is the content for this chapter, which is including the work and energy principles, applications of determining the deflections of truss, and virtual works methods or unit loss method for the calculations. So principle of energy of work, okay, this is a greater use in providing rapid approximate solutions of problems suitable for finding the displacement at points, okay, subjected to the load. And energy is referred to strain energy, which is U. Okay, so you can see that when you have a load pulling, okay, so pulling you will have an external force, external work, which is the work, and then you will cause a displacement, okay, elongations, okay, so it's equal to force times the displacement, and this is the internal work. So the external work will be equal to the internal work. Okay, so for the conversations of energy principles, so external work is equal to internal works, and external work, the work is equal to the strain energy, okay, that caused by the displacement. So U is equal to half P and then the displacement cost. So the formation of this, after you switch this, you organize the equation, it will become the formation equal to PL over AE. Okay, P is the load applied, and then the length, and then the A and the E. Okay, so U is equal to half P PL over AE. So half P times D, the deformations. Okay, so the U, okay, the U is equal to half PL is equal to P power of 2L over 2AE after you reorganize these equations. Okay, the total displacement in millimeter. Okay, so normally we are using in the millimeter. So the principle of virtual works, okay, so from for other points of the locations, or to determine the displacement of a truss joint when the truss is subjected to number 1, an external loading, number 2, temperature change, and number 3, fabrications errors. So what we will have to learn here is the external loadings calculations. Okay, so for example, you can see that consider the truss below is designed to calculate the vertical deflections at point C. Okay, so you can calculate at when the load applied at here at this joint. So what is the displacement at joint C? Okay, the U, the calculations. So you can calculate later with the example from these chapters. Okay, so before the displacement occurred, apply a unit vertical load at this point and to this point of the dummy structure, okay, as the figure below. So due to the unit load, the external work is equal to 1 times the difference of this displacement. Okay, so we can see that when you apply a 1 unit load, okay, so the external work is equal to these equations. Okay, you will be more clear when you face the calculation, so we will go through the calculation later. So the external work is equal to the internal work. Okay, so this displacement is equal to F times U times L over AE. Okay, so you will calculate later using these equations. Okay, so step to find the deflections at C. Okay, you can see this. Okay, so what you can do to calculate the deflection at C is number 1, determine all forces. Determine all forces in the truss member due to the external force. Okay, as usual, you calculate like in the chapter 2. Okay, you calculate the member force for each members, and then you remove number 2, replace the external load with 1 unit load at the joint C, where you want to find the deflection at C. So we will replace external load with 1 unit load at C. Okay, in the vertical directions to find the internal forces, the U. After we replace the 1 unit load, then we calculate again the all member forces for each member. Okay, and then we will calculate the this is mu, sorry, F mu L over AE. So the value of each member, and we will add it, we will cumulative it, and then it is So if the value of this is positive, then that shows that the direction of the deflection is same as the direction of the unit load. So we will have an assumption of the direction for the unit load. So the final answer, if it is positive, means that the direction of the deflection is same with what we assume. But if it is the opposite, it is the negative, so means that the direction is going opposite way from the unit load we apply. Okay, so let's we go to the example. So this example 1, the cross-sectional area of each member of the truss shown in the figure below is A. Okay, is provided the value A is 400 millimeters square, and then E is 200 gigapascal. Assume the members are pin connected at their ends. So the pin connected at their ends. Okay, and then determine number 1. Okay, A. Vertical displacement of joint C at joint C if a 4 kilonewton horizontal force is applied to the truss C. Okay, so first step what you have to do as explained now is, okay, this is joint C, joint A, joint B, and then what you have to do is, as usual in the chapter 2 before, first you need to determine whether it is statically determinate or indeterminate. So members are 3, reaction force are 3, and then the joints are 3, so 6 is equal to 6 after you solve it, and means it's prove it is statically determinate. And then you will calculate the reaction force at support A and support B. Okay, so you will get H share equal to 4 kilonewton, VB equal to 1.5 kilonewton going upward. Okay, and then VA is going downward. Okay, negative 1.5 kilonewton. So here you get negative 1.5 kilonewtons, means that the load is going downward. It is not what we assume going upward. So what you have to be careful is the positive and the negative you get with the direction of the force. So once you get the wrong one, you will carry forward with it, and then every time you will be wrong, and then you will not able to get the imbalance, the equilibrium system. Okay, the value. Okay, so make sure you don't be confused with the positive or negative and then the direction of the force. So this one you already learned before in the static dynamic and mechanics of material, so I will not explain on this much. Okay, so once you get this, okay, you can see that you already have the value of the force, 4 kilonewton at H to the left. Okay, and then 1.5 to downward at VA, 1.5 going upward at VB, and then you have a 4 kilonewtons. So what you have to do is you need to find the member force for each member. Okay, so you can start with the point A. So 1.5 going downward, then you will get 1.5 going upward, and then when you solve using the ratio of 1.5, you solve it, then you will get 1.5, and then you will get vertical horizontal is 2. So you're using this value, then you can find 2.5. Okay, remember, so the square root 1.5 power of 2 plus 2 power of 2, then you will get the value of this. Okay, so you will get this is the tensions, and then this one you get 2 plus 2 equal to 4, so this is also in tensions. Okay, so this is 2. Okay, so going here is also 2, and then 1.5 going upward, so here you will have 1.5 going downward. So this is moved to going up, the load is going to the joint. Okay, so you will have also the force opposite to the joint to here also, so you will have a 2.5 kilonewton which is in compression. Okay, so now you get all the member forces. So this is you using the alternative method. Okay, 1.5 over 3 is equal to x over 4 for this one. Okay, the 3 meter and the 4 meter here, 4 meter here, so you get x equal to 2 for this one. Okay, so this one you are using alternative method. So using alternative method is faster. You don't need to draw each joint, you just draw back the structure and then you put in the value, and then you can solve it quick. Okay, so after you found the values for that one, or the member force due to the external force, then you will replace the 1 unit load at the joint. Okay, so you can see that find the vertical displacement of joint C, calculate the virtual force mu. All origin forces are neglected, so you remove the 4 kilonewtons there, and then you remove any other forces there. So, and 1 unit load method is applied at C. Okay, so now it is no external force again, and then you put 1 kilonewtons, you assume going upward. Okay, Again, the same thing. First, you need to calculate the reaction force at A at the B. So you will you will get VA, you will get VA equal to 0.5 kilonewton, which means it is going downward, and then you will get VB is negative 0.5, which is going downward. Okay, you assume going upward, that's why it's going downward when you get it. Okay, and then HA is equal to 0 because there is no horizontal force here. So you input into, you draw again the truss, and then you put in the value of negative, you put in the value of 0.5 kilonewton going downward, 0.5 going downward, and then 1 going upward. Okay, so you input this, and then you will start to solve from joint to joint using the alternative method. Then you will get the value of member AB is equal to, in compression, 0.67. okay, and then AC you get 0.836, okay, in the tensions, and then 0.836 in the tensions. So after you get all of this, this is from the external forces, and this is from the internal force. This is from the unit load you apply. Okay, then you put into the table. Why you have to put into the table? Because you need to find you need to find all the real forces and virtual forces. You need to put into it, and then you calculate the total F mu L over AE. Okay. So later you will have to you need to put in the value for A, the B, the distance is 8. Okay, from A to B is 8, AC is 5, CB is 5, the length, and then the force caused by the external force, okay, 2 in the positive, tension in positive, okay, compression in negative. Remember this. Okay, so it's 2.5 for AC, okay, and CB is 2.5 in compression, that's why you have a negative. And for this, the mu is, you see, this one, AB is in compression, means it is negative, and then AC and CB is 0.836 in tension, that's why it is in positive. So you times the value for this, 8 times 2 times negative 0.67. Okay, if it is negative, then you put negative. If it is positive, you put positive. And then you total up this value, you will get negative 10.72. Okay, so after you get this value, you need to input into the vertical displacement equations. The displacement at VC is equal to total F mu L over AE. Okay, the equations, remember. So provided 200 gigapascal for the elastic, the Young modulus, the E. Then you convert it become 200 times 10 power of 6 kilonewton per meter square, and the A is 400 millimeter square is equal to 4 times 10 power of negative 4 meter square. So AE is equal to, you times this and this, you get 80,000 meter square. So the displacement is equal to negative 10.72 over 80,000. So you get negative 0.000134 meter, and after you convert it back to millimeter, you will get negative 0.134 millimeter. You get negative here means the values, okay, the displacement are opposite the direction that we assume. Just now we assume going upward. So what we get here is we get it going downward. Okay, because when it is opposite of the unit weight at the unit load. Okay, so for here what you have to be very very careful is the unit weight, the unit. Okay, so this one, okay, this one I will not repeat much, but for the unit you need to be careful. If you want to start it from the mm, then you need to be careful with the mm and so on. Please make sure you will be careful with it. Okay, so the unit is always will cause any problem with it, so double check everything. Okay, the millimeter. So let's we go to example 2. So determine the vertical displacement at joint E of the truss shown below, okay, in the figure below. So the modulus of elasticity, this is typing error, shown, okay, is 210 kilonewton per meter square. Okay, and the data is as follow. So you have support A, at here, support G at here. Okay, here you have a vertical forces and horizontal force. Here you have a roller, means only one force. You have 20 kilonewton applied as H, F and E. Okay, so each span is 18. Okay, and then you have a height of 18. So already here provided the length, okay, for each member. Okay, AH, HG, GH, heavy, AB, BC, CD, and every member of it, you already have the A and the length. So what you have to do is the calculations. So again, the calculation are the same step. What you have to do is first, you need to calculate the reaction force at A and at G. So from the calculation, you will get VA is equal to 80, VG is equal to 80 going upward, and the VA is going downward. Here you can see that here is a negative after you calculate. So VA here is negative going downward. It is not going upward. Okay, and then HA is equal to 0 because there is no horizontal force. So after you calculate it, then you will find the member force of each member using the alternative method. Then you will get the value of each member. You can see it here. Here already show you all the values. Okay, for the members here, you can see that this is in the compression. Okay, 40, 40, 40, 40. And then this one is in tensions, 44.72. Okay, 66.9 for the tension, 66.9, 44.72 for the tension. And this one is also in tension, this one in compression, tension. Okay, so remember when you calculate it, okay, when you plot the values, you put in the directions of the force, then it will represent direction of the force for this, then it will represent either the member is in compression or tensions. When in tensions, okay, the force is pulling inside and the pulling outside. Okay, at the force when in tension, the force is pulling outside, so the member will have a force, okay, in opposite of it. Okay, so this one I already explained in the chapter 2 before, so I will not repeat in this chapter. So you calculate it, you will get these forces for each member, and these forces we will use to put into the table for the calculations. Okay, and then solution after that, okay, the internal force of member due to the real load 20 kilonewton at each joint. This is the more organized of the picture, then you will get this. Okay, so this one is from the previous one, the same one. If you didn't put in the direction here, then you need to put in the negative here. Okay, either it's in compression or in the tension. Okay, so next, so determine the vertical force at joint E. Okay, determine the displacement, sorry. Okay, determine the vertical displacement at the joint E. The forces of the member due to the unit load 1 kilonewton at joint E is applied. So now we want to find the displacement at point E. Then we remove the forces applied, the external forces applied at joint E, and then we calculate again the reaction force. Then we will get RA equal to -1, means it is going downward. RG is going upward 2 kilonewton. Okay, so after you calculate this, again you will calculate the member force. You will keep repeat the same thing, like keep calculating the member force. Okay, so you calculate it again, then you will get this member force of each member. You can try it at home. Okay, to do this, either you will get the same answer exactly like this or not. Then we go to next slide. Okay, so after you calculate that also, then we will start to put it into table. Okay, L and A you already provided, and then you will get L over A, the value, and then the F, the mu, and then you calculate FUA. So if it is negative times negative, then you will get back the positive. Okay, and then you calculate everything, then you total it up, then you will get the total FUL over A. And then the displacement at joint E is equal to FUL over AE. So you put it at everything already, and then you divide by the modulus Young, you will get 3.76 millimeter. Okay, for the total displacement at joint E. So if you want to find the vertical displacement at other joint, you will need to put the unit load at the other joint, then you can find it repeat the same thing. You will calculate the displacement at each joint where you want to find. Okay, so again, the unit load and the unit is very crucial, so make sure you will get it correctly. Okay, so this is example number 3. Okay, you can see that this one is you want to calculate the vertical displacement at joint E of the truss as shown below, figure below. So the modulus Young is 200 kilonewton per millimeter square is equal to 200 gigapascal. The cross section area of each member is 1000 millimeter square. So you get this. Again, you will calculate the reaction force and then the member force caused by the external forces, and then you will remove the external forces, you apply with 1 unit load, and then you will calculate again the reaction force and the internal forces, and then you will calculate using that formula using that tables, then done. So this is, you can do your own practice for the method on how you do this. Okay, calculate the reaction force and then the member force. Okay, then remove the external force, you replace with 1 unit load, and then calculate again the reaction force and then the load at each member. Okay, then you make a table, put in everything, the F, the mu, then make a table for F mu L over AE, then done. You will get the answer of 6.28 millimeter. Okay, so this is another example 4. Okay, you can see that it is also the same thing. It provides you the value of E, the cross-section areas, and then you want to find the vertical displacement at C, and then also the horizontal displacement at C. Means that here you want to find the vertical, okay, direction and the horizontal. So what are the steps? Okay, so first, again, you want to find the force of member due to the real force, which is the force applied. Okay, so first you get the reaction force for point A and point D, and then you calculate the member force by using the alternative method. Then you get all the values. Then you remove all the force applied. Okay, and then you replace the 1 unit load at point C for the vertical displacement. You put in the vertical direction. Then you calculate the support reaction and also the member force. After that, you calculate the horizontal displacement by apply the 1 unit load at the point C horizontally, because now you are changed to calculate the horizontal displacement. Also repeat the same thing, calculate the reaction force, and then you calculate the member force. So once you got everything, you put in the value into the table, the L, A, F, mu1, mu2, and then F mu1 L over A. Okay, this is for the vertical, this is for the horizontal. You total everything, then you will get again the value F mu L over A E. E, they put it at the last, so you calculate also for the mu2. So you get vertical deflections is equal to 1 mm going downward, and then the horizontal deflections at C is 26 mm going to the right. Okay, so you can do this and practice and check with your own calculation, either you get the same answer with this example or not. Okay, so thank you everyone for watching these videos. Hopefully I help you with these videos for your chapter 3. Thank you.